Come on, you're not that excited about math? Oh my God, it's Unit 1. I'm a little sad though, because I have my Dunkin' Donuts coffee, but it's just water. Yeah, today it's just water, so I might have to get some coffee later, but maybe for now I'll just stick with water. Anyway, this is Unit 1, Algebra 2, Common Core. This is going to be Day 1 notes. So if you're here for Day 1 notes, you're in the right place. If you're not here for Day 1 notes, you're not in the right place. What happened? Why does that look like that? That's weird. All right, there we go. I don't know what happened there. Anyway, okay, Day 1 notes. Here we go. Let's get started. Very simple. My name for you today will be called Mr. Key. I, of course, am Mr. Krause, but we're going to call me Mr. Answer Key for today. All right, Day 1 notes. This should not be anything that's very new to you. Almost all of this you should have learned in Algebra 1. Hopefully you did. I think my camera's a little messed up. I don't want you guys to miss all of my hair. Get it all in there. So if I get too close, you kind of don't get a good sense of what my hair looks like. All right, so this is just a visual. Okay, we're going to talk about relations and functions. Okay, today we're going to talk about relations and functions and what are they. So let's first talk about what a relation is. Relation is very simple. It's not very complicated. Relation is just a collection or set of points. Now you notice how big it is, right? It's like all-encompassing. It's huge. Now, within the set of relations, that big, huge thing called relations, we have something called functions. Now, for me, because I'm a lazy math teacher, I'm not going to write the word functions out all the time. Also, my penmanship starts to wane a little bit as we go on. So I'll just usually use the initials F and C for the word function because it's a little bit easier. All right, function. So what you need to know about function, first of all, it is a relation. So in other words, and that should make sense because it's a small circle within a big circle. So all of these things down here are first and foremost a relation in which... Why did I just misspell which? Oops. Which, I don't know what I was just trying to do. Which each x, and that's of course the input values, has one and only it's only y or output value. Okay, I'm going to work on my penmanship. All right, so every x has only one y. Each input has only one y. And so the input, which we'll call the domain, it's kind of like if you think about this as being your function. This is being your function, right? We're going to have the domain, which is the input. And these are your x values. And then what pops out are the range or your output. And these are your y values. And that's probably behind my head, but it says y values right there behind my head. I'll even raise it so you can see it. The y values. Oops. Y value. Y values. Okay. So, relation, just a set of points. Really no rules. A function is a relation, just a whole bunch of set of points, but in particular, each x value has only one y value. And we usually represent relations and functions in a couple of different ways. We could use ordered pairs. There's your set or collection of points. We can use a table where you have these are your x values, of course, and these are your y values. This is the input. This is the output. Input, domain, output, range. Or I can graph it. Or I can do this weird thing called a mapping function, where this is the input, of course, the domain. And this is the output, which, of course, is the range. Should have seen these before. So identify the domain and range. So one of the things I want to make sure you guys understand is I just got to move my graphics tablet a little bit. Try to get it a little bit better place value. Much better. One of the things you want to do whenever you identify domain and range. It's not good enough just to start listing out values. You have to actually identify, and you got to say, okay, look, I'm going to talk about the domain right now. And whenever you list out a set of values, you should do so using these curly brackets. So it doesn't matter. All four of these represent the same relation. In this case, I believe it's a function. We'll take a look at that, I think. But if you look at the x values, -1, 1, and 4. So those are your domain. The range, very simply, is going to be all the y values. So that would be 1, -3, and 2. Should you list those in order? Probably. It's probably better just to list them in order. I'm going to actually do that. I don't know if it makes a huge difference, but generally in math, we like to have things ordered. So we'll go -3, 1, and then 2. And then I just said which of these allows you to easily see the domain. This is probably the hardest, right? Because you got to go, okay, what is that point? It's -1. You actually got to think about how every point is. This is probably even the next hardest. These two are probably the easiest for domain because there they are. There's the domain, there's the range. There's the domain, there's the range. So those are probably the two easiest, the table and the mapping function. I don't know why I'm having such a hard time. There it is. The table and the mapping function. These are ones that are easiest. Now, do you always get them like that? No, not at all. All right, so let's take a look at this. What we're going to do is we're going to graph all three of these points. Hopefully graphing points is not that big of a deal for you. Hopefully you can do that pretty easily. I'm, crossing my fingers. So -3, -2. Boom, there it is. -2, 2. -2, 2. 1, -1. And 3, 1. 3, 1. So if I had to list out the domain, I would list out the domain. If I did these domains in order from left to right, it would be -3, -2, 1, and 3. If I had to list out the range, again, I'm going to list out the range also in order. So I'm going to go from the lowest going up to the highest, because that gives them to me in order. So the lowest one is -2. The next lowest one is -1. Remember, we're looking at the y values. The next lowest one is 1. And this highest one up here is 2. Those are just discrete numbers. They're just points. Okay, and anytime you list out discrete points, this point and this point and this point, it has to be done in curly brackets. You don't have a choice, okay? This is kind of boring. So a mapping function. So you'd put the input values here, 3.4, 5.0, 7.0, and 9.2. And they just all happen to be in order. That's why it's kind of boring. I should have probably picked a more exciting example than this. But anytime you lift out a mapping function, what you're going to do is you're going to put the input here, the output here, and then you got to draw arrows. So 3.4 goes to 30, 5.0 goes to 40, 7.0 goes to 50, and 9.2 goes to 60. Listing out the domain, 3.4. Wow, that's really weird. 5.0. Don't put 5, put 5.0. They're more accurate. You be more accurate. 7.0. There's a difference between 5 and 5.0. If you ask your chemistry teacher, I'll bet you they'll tell you that. Right? You ever heard of anything called significant digits? Sig figs. We used to call them sig figs. I don't know if they do that anymore. We were a lot cooler back then. Oh, yeah. We're cool. 30, 40, 50, 60. One of the biggest complaints I get from my students is, I can't make those curly brackets. They look so weird and funky, and I can't do it. Suck it up. You can do it. All right, let's take a look. So this is more of a cooler mapping function. So what we're going to do is we're going to take a mapping function, and we're going to create a graph. So the easiest way to do this, let me get back to fuchsia, or whatever color that is. I'm a guy. I don't even know what fuchsia is, but I'm guessing this pink color is kind of fuchsia-y. 0 goes with 75. So if I had to list these points out, I'd list them out as 0, 75, right? So I'm going to go 0, 75. And then 24 goes to 40. 24, 40. But 24 also goes to 50. And finally, 36 goes to 38. 36 goes to 38. Now, the domain is really, it's really kind of uneventful and exciting. There it is, domain 0, 24, 36. It's the input values. The range is the output values, which is in order 38, 40, 50, and 75. Okay, now, determine if the relations above, these ones above here, represented 1 through 3, are functions. Explain why or why not. So remember, a function is a set of points, or it's a relation where every x has only one y. So if we go back up to here and we look at these x's, negative 3, is there another negative 3 that has something different? No. There's negative 2. No. 1. So every x value is distinct. Well, it's kind of what you're looking for is repeating x value. So every x value. In this one, every input value, these are my input values, only has one output value. So yeah, that's a relation. But let's take a look at this one. And your problem child here is this 24, right? You'll notice that 24 goes to two different locations. It goes up here to 40, and it goes down here to 50. So it is not a function because this one input value goes to two different places. Now, if you were to look at that on a listed out in points, it would look something like this: 24, 40, comma, 24, 50. So one of the things we look for is repeating x values. If we see repeating x values, it generally means it's not going to be a function. So 1 and 2 are, how about this? I realized I put 1, 2, 3 down here. So 1 and 2, I'm just going to do this, are functions. Why? No repeating. I just misspelled repeating. I always misspell repeating. I don't know what it is about that word. Receipt's another one I can't spell. Repeating x values. Now that's the kind of tricky way to say it, but really what we have is each x has one and only one y value. And number 3 is not a function. Now, why is it not a function? Because, you guys know the symbol for because, BC? It just stands for because. Because the number 24 has two different outputs. That's it. Very simple. All right, I got to take a break, get something to drink, and I'll be right back. You're going to find out that I always tell you that I'm taking a break. I don't know why, because for you it's like nothing happened other than maybe my head jiggled a little bit because it wasn't in the same spot. But, with computers, you want to kind of save every once in a while. I remember one time I didn't save for like over an hour. I did a video and I didn't save, and I wasn't even recording and I didn't even know it. So, and one time the computer crashed on me, so that wasn't good. So I save every once in a while. So ignore me when I say I got to save, but whatever. All right, so what we're going to do is we're going to determine if each relation below is functions why or why not. Okay, let's get to like, I don't like this purple. Is there a better purple? Let's go more colors. Oh, yeah. We go hot purple right there, baby. Yeah, that's a good purple. Okay, so what we're going to look at these x values. So we got 1.1. Is there another 1.1? I don't see one. I see a 3. No other 3s. I see a 5, and I see a 10.6. So this is, yes, it's a function. Each x has one and only one y value. Now, I'm not going to spend a lot of time on this. Let's just take a look at it. So we got this one right here. Is this a function? If I look at it, what I'm looking for is repeating x values. And you see this 120 here? And you see this 120 here? No, 120 has two different output values. Is that behind my big old head? It's a good thing I'm saying things. That has 2 output values. Okay. Let's move on. All right, so you have to look at these. 5 only has 240 something. 6 only has 225. 7 only has, and each one of these x values, these are the x values, right? If you had to list these points, it would be 5 and almost 250, let's say. This would be 6, 225. This would be 7, 215? Oh my gosh. 7, 215, something like that, right? So each one of these x values, so yes, this is a function y. Each x has only one y. When you're looking at mapping functions, you're looking for a double arrow situation. And we're going to talk about double arrows going both ways when we talk about one-to-one functions. But for now, we're just looking at it going one way. And I see right here that this x value has 2 different y values. So this is not a function. Okay, pretty simple, pretty easy. All right, so again, we're going to take a look at these graphs and things, and I just want you to take a look at these because I'm going to use it as a way to remind you of something you learned when you're a freshman in Algebra 1. But this is a function, and why? Well, if I look at each one of these x values, it only goes to one place. A 3 only goes there, a 4 only goes there, a 5 goes here. Is this one over here a function? It is not. Now, it is a relation. These are, in fact, relations. But this is not a function. The 1 is not a problem, but look at this 2. The 2 goes here, and the 2 has an output value here. So if you were to look at these listed out in values, one of them would be 2, 2, and one of them would be 2, 3. And see how we got the repeating x values? Therefore, it's not a function. Okay, and we also have a problem here at 4. 4 goes to 4, but 4 also goes to 5. So this is not a function. And I think if you remember correctly, or some of you are probably screaming it out right now, you learned something called the vertical line test. And this really just says this. If a vertical line by the way, vertical lines are lines that go straight up and down, just so you know. If a vertical line intersects the graph only once, then it is a function. So if I was to go back up to the example we were working on the last one, and that's the one I was saying, you're going to start to realize in a second what this is. If I was going back up to look at this, you don't have to erase it, but just take a look. If I draw a vertical line, you got to draw it straight up and down. If I draw a vertical line, I only hit it once. 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 So this is, in fact, yes, a function because it passes the vertical line test. But if I come over here, I draw a vertical line here. Well, that's okay. But what happens if I draw a vertical line here? It hit 2 different points and therefore fail. Okay, so here's what I want you. What we're going to do is we're going to take a look at these. We'll come back to the odd even stuff in just a second. But we're going to take a look at all 9 of these, and we're going to quickly tell if they're functions or not, just based on the vertical line test. Right? So if you draw a vertical line in and it only hits it once, then in yes, it is a function. So we're going to write yes here. This one is also a function, yes. Now we got to be careful here. I'm going to try to zoom in here. I really like to move over. I don't know why I can't move over. There we go. Got to use my mouse apparently. All right. So if I draw a vertical line here, it hits it once, hits it once, hits it once. And then you're thinking to yourself, okay, what happens here? So I'm drawing my vertical line in. I'm just going to stop right down, pretend like I go through there, go through there, go through there, go through there, go through there. Now, if you notice, this is an open circle. An open circle is not part of the graph. So you could think about it being like an open circle like this and a line going through, so it's not touching it. But this closed circle down here, it is touching it. So it doesn't touch it here, and it does touch it here. So if I was, in fact, to draw a vertical line through, a little skinnier line, hopefully, if I draw a vertical line through, it doesn't hit it here. It looks like it hits it there, but remember, it's a big open circle. But it does hit it here. So this is, yes, a function. Only hits it once. Why can't I move over? I don't understand. I got to figure out this left and right movement. I thought I had it figured out. A circle is not a function. Fails it. I'm going to... Okay. Oh, I'm going to have to blow it back up anyway. All right, this one is a function. You can only hit this thing once. This would probably take half the time if I didn't have to move things around. Somehow I'm going to figure out why I can't see this. Now, this is a little bit trickier to look at because everybody thinks when we look at this right here, what you need to understand is it's when I draw this, it's getting closer and 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 closer. But it only hits one point there, and then it gets closer and closer. So if you were to draw a vertical line in, although it looks like it hits more than one point there, it doesn't. This is also a function. It's the cube root function. We'll find that out in a couple of days. Are all these functions? I guess they're all. Are these all functions? Well, that was bad. I should have made... Oh, no, the circle is not a function. All right, this is a function. Remember, it goes to the open circle, doesn't hit it, but hits the closed circle. This is a function. Even though it looks like it's closer and closer and closer and closer, it just keeps getting smaller and smaller and smaller and smaller and closer to this one, but it never crosses it. So this is a function. And this is also a function. That's the cosine curve. All right, so let's go back up and talk about even and odd functions. Even functions. You'll know it's an even function if it is symmetric with respect to the y-axis. In other words, if you use the y-axis as a mirror and you see the exact same thing on the left and right, it's a function. An odd function, you can think of it two ways. It's symmetric with respect to the origin. So it's symmetric with respect to the origin. Or it has 180 degree rotational symmetry. It means the same thing. In other words, if you take your paper and turn it upside down, does it look exactly the same in the exact same place? If it does, it's an odd function. All right, so let me grab my, I don't know, what am I going to grab? Let's go grab a green, let's grab a thick green pen. Here's my thick green pen. So if I draw a vertical line down through this, do I see the, man, that's way too thick. I like the other version of this. I can put a ruler down. If I draw a vertical line through on the y-axis, if I go on the y-axis, do I see the same mirror image on the other one? No. If I turn my paper 180 degrees and I turn that whole thing around upside down, would it look exactly the same? So no, this is neither odd nor even. I'm just going to put neither odd or even. If I draw a vertical line through here, right, I see the same on the left and the same on the right, so this is even. This one, it should be obvious, it's neither. Now this one has both rotational, 180 rotational symmetry, and, we said it was not a function, and it has symmetry with respect to the y-axis. So you might think, oh, it's an even function and an odd function, except we already said it's not a function. So if you say it's not a function, don't start telling me it's an even function. That's kind of silly, right? If I draw, now remember, it's not drawing the axis of symmetry. If for even function, it has to be symmetric with respect to the y-axis. And are those mirror images on either side? No. So this is also neither. Also, if you turned it 180 degrees, clearly it's not. This one does not have symmetry with respect to the y-axis. For example, that point is not a point over here. But if you took your paper and you turn that 180 degrees, now if you got your paper in front of you, turn that thing 180 degrees, you'll see that it lands and looks exactly the same. So this is actually an odd function. This one is very, very, very close to being an odd function. But this point here, when I spin it, goes to... Oh, no, it's not, because it would go over here to 3 something. So this is neither as well. This is neither. Now this function here, if I draw a vertical line down the y-axis, I see that it looks exactly the same on the left and the right. This is an even function. All right. Again, I'm taking a quick pause. Now you notice something different. I had a cup in my hand. Sorry. So now we're going to investigate odd and even functions algebraically. So this is a little bit more fun. We'll actually be doing some math now. I hate that green pen. It's a ugly color. Let's go back to purple. Purple's a cool color. So we can recognize algebraically. Now we get to finally do some math. Jeez. Algebraically, we are going to determine a function is even or odd. So it will be an even function if. Now, whether or not it's even or odd, we always have to evaluate f of negative x. That's what I was about to say, but I didn't put it there. Forgot it was there. We always have to evaluate f of negative x. So if it's an even function, then f of negative x is equal to f of x. In other words, if you plug negative x into the function and you clean it up a little bit, it turns out to be the exact same original function. Therefore, it will be even. If, however, you evaluate f of negative x, boy, it's hard to write like that, and it equals negative f of x. In other words, it equals the negation of the original problem, then it's an even function. Now, I know you don't understand that, but in a second you will. So let's take a look and investigate whether or not these are even or odd. Now, I could graph these. I could graph these. 4x squared. Oops, that's not what I want. Oops, I'm turning my calculator on right now. Hold on. And I'm going to graph these. Why can't I go left and right? I don't understand why I can't go left and right. All right. So if I graph this, and I can graph it and look at it and see like we just did. What is it? I'm going to go graphing. It's 4x squared plus 11. Of course, it's way off my screen, so I can't see it. I'm just going to change this number to like 20. And there it is. And if you look at that, can you see that it looks the same on the left and the right? It's going to be an even function. But that's not good enough for me. I have to be able to tell it algebraically. So I'm going to check. So this is our original function. We want to see if when we evaluate f of negative x, that we're going to get back that same exact thing. So if you remember from a long time ago, what we do is we take whatever's in here and we plug it in for x. Plus 11. Okay. Well, what is negative x times negative x? What is negative x squared? Negative x times negative x. Negative x times negative x is x squared. So this just turns out to be 4x squared plus 11. Well, isn't this the same as this? So what we'll say here at the end is since f of negative x equals f of x, f of x is an even function. All right, let's take a look at another one. And by the way, it does, eventually you're going to say, oh my God, it's got even exponents, it's even, it's got odd exponents, it's odd. Generally, that could be true, but it's not always true. Okay, so you got to be really careful. So here, this one looks like it got a 5 and a 1. And again, if I was to graph this, 2x, what was it, to the 5th? Minus 4x. If I was to graph that and look at it, right, it looks like it's got symmetry with respect to the origin. That point goes down there. So it looks like it's going to be an odd function, and it's probably true. But I'm going to tell you right now, you're going to have to, on test or quiz day is to show it to me that g of negative x, does it equal negative g of x, right? So we're going to check it out. So 2 negative x to the fifth minus 4 times negative x. Now negative x to the fifth is negative x times negative x times negative x times negative x times negative x, right? Don't every two of these make a positive? So that's a positive, that's a positive, that's a negative. So this turns out to be equal to, g of negative x turns out to be equal to, this here really is just negative x to the fifth. So it turns out to be negative 2x to the fifth. The key thing is, if you have an odd number of negatives, it's negative. And then this here is plus, negative times negative is plus 4x. Well, if I take out, and that's the key on these, you got to factor out a negative. If I factor out a negative from here, negative, and I take it away from this, I end up with negative 2x to the fifth. Take away a negative from this, I end up with minus 4x. So isn't this is g of x with a negative out front? So therefore, since g of negative x equals negative g of x, g of x is an odd function. All right, we're going to do a few more of these, more practice. So I'm looking at all these exponents, and I'm thinking probably going to be even. All right, we're going to quickly check it. F of negative x, negative 2 negative x to the fourth plus 3 negative x squared minus 1. Now I told you if you have an odd number of negatives, it's negative. If you have an even number of negatives, it's positive. So negative x to the fourth is just positive x to the fourth. So this just turns out to be, there's a negative 2 here. And this is just x to the fourth. Plus 3, this is just x squared. Minus 1. And since this is exactly the same as this, it's even. So since f of negative x equals the original f of x, I'm just going to write even. Or mostly even. All right, this one's got an odd exponent here, an odd exponent here, and I got this little 1 out to the side. So this one looks like it's probably going to be odd. But we got to check it. So g of negative x equals 3 negative x to the fifth plus 5, times negative x minus 1. Now remember, this is an odd number of negatives, so that's negative. So this turns out to be negative x to the fifth. With the positive 3, it makes it negative 3 x to the fifth. This is just minus 5x. And then minus 1. Now the final thing we want to do to check if it's an odd function is factor out of these, factor a negative out of all of those. So we'll take out a negative, and we'll end up with 3x to the fifth plus 5x plus 1. Now remember, when you factor out a negative, what you're really doing is just changing all the signs. That's all we're doing. All right, so let's take a look. Is this the same exact as the original? It's close, but it's not. Here's the problem right here. So g of x is neither odd nor even. Okay. Oh my goodness, we have 4 left. Huh? These take forever to do. All right. Oh wow, that's should have come over to the other side. That's weird. I thought I fixed that. So we're going to check f of negative x. So I do negative x cubed minus negative x. Odd number of negatives, so that's negative. And negative times negative, that's positive. Factor out the negative. Look, it's got odd exponents. It's probably going to be odd, so you're going to want to factor out the negative. If it's got even exponents, they should just look exactly the same. So let's see. Factor out a negative, and I end up with x cubed minus x. And this is, in fact, the original function. So since f of negative x equals negative f of x, odd function. I see even exponents, so it's probably going to be even. Sorry about the g of x being over here. So we're going to check g of negative x. Negative x to the fourth minus 4 negative x squared. I don't know. I hope I have an example where it's neither with even. So x, this is an even number of negatives, so that's just positive. So this is just positive. Don't worry about you can't do the negative 4 times this. You got to do this exponent stuff first. So this negative x squared you have to do first, which makes it, that's positive x squared. That's really positive x squared. And then we have a negative 4. So negative 4 x squared. So this is even. Man, why did it, I don't understand why it came out like that. I don't know, I must have adjusted something. Negative x cubed plus 1. So an odd number of negatives is negative, so this is negative x cubed plus 1. Factor out a negative, negative x cubed minus 1. Is this negative of the original? It is not, so this is neither. And this is a really weird looking function. Let's go take a look at it graphically real quick. Remember what's on top. 3 over x squared minus 9, I believe. Now, if you draw a line right down the middle, doesn't it look like the same on the left and the right? So it certainly looks like an even function, and we're going to find out that it is. So k of x, k of negative x equals 3 negative x squared minus 9. So k of negative x is equal to 3 over, this is just positive, x squared minus 9. So since this is the original, it's even. So you can use your calculator to help you, but you're also going to have to do it algebraically. And I'll give you some practice for those in the homework. All right, I think we're almost done. Hope we're almost done. Oh man, I forgot this day's really long for some reason. I need to toss some of this stuff out. I might toss some of this stuff out. So writing a function y equals f of x. This just says y is a function. Y is a function of x. I mean, we've done it before. Write a function. So in 9th grade, you might have written y equals negative 3x plus 4. But, you know, you're growing up now. We want you to write it in function notation. F of x equals negative 3x plus 4. And so that's the answer to this question. Write each of the following in function notation. I'm not even sure why I did this. Abs value of x plus 8 minus 2. F of x equals x squared minus 4. Now you can also, this is t though, you got to be careful. F of t equals, I even made a mistake on my answer key. That's embarrassing. 10 to the t. Now, why did I have to use t? I used t because that's t, and these I had to use x. These shouldn't become any surprise. F of 5, you just plug the 5 in for x, right? So 5, I always usually use parentheses. It's always a pretty good idea. Plus 17, which is just 22. G of 0 is equal to the absolute value of 0 minus 1 plus 2. Be careful. This is really the absolute value of negative 1, which is just 1. So this turns out to be 3. H of negative 1 is negative 1 squared plus 7. Negative 1 squared is positive 1 plus 7 is 8. This one we're going to do t of negative 2. You might want to use your calculator for this one. We won't. Negative 2 cubed. Negative 2 times negative 2 times negative 2. 2 times 2 times 2 is 8, not 6. 3 negatives is negative, so that's negative 8. This is going to turn out to be positive 4 times negative 2, so that's negative 8. That's 5 times negative 2, so that's minus 10. Minus 8. Well, I believe if you do all that, you end up at just minus 34. Am I right? And then I ask you to do all these f of 3. So let me just go. I'm going to use my the f function is x plus 17. So this would be f of 3 is equal to 3 plus 17, which is 20. I got it right here. G of 3 is equal to the absolute, oops, I forgot the absolute value bars. I'm running out of space. Absolute value of 3, was it minus 1, I think? Yeah, minus 1 plus 2. So this just turns out to be the absolute value of 2. 2 plus 2 is 4. H of 3, the H function says 3 squared plus 7. 9 plus 7 is 16. And T of 3, oh man, this one's going to be a pain. Sorry about this. So this is definitely where we want to use your calculator. Let me take a look. Oh, I got it right there. So it's 3 cubed minus 2 times 3. Oops. 3 squared plus 5 times 3 minus 8. So 3 cubed is 27. This is 9. 9 times negative 2 is minus 18. This is 15 minus 8. So 27 minus 18 is 9. 9 plus 15 is 24. 24 minus 8 is 16. Did I get that right? I did. Yay. All right. I think this is the last page. This should be quick. Real simple stuff. This one says, if k of x is defined, so this is k of x right here. What is the value of k of negative 2? Anytime I put a number in there, that's an x value. So all you got to do is go look for that x value right there. I'm going to highlight it in blue. So the question is, k of x is defined by what is the value of this? So whenever I ask you this, you have to know that, oops, whenever I ask you this, you have to know I'm looking for the y value. So x is negative 2, so that means k of negative 2. In other words, the y value is just positive 2. What is m of 7? Again, I'm looking for the y value, the output value. So I go find 7, and the answer is m of 7 equals 50. N of 0, so I go look for the 0. I follow the arrow down, and 75. And P of 1. So I go look for the x value of 1. There's the x value of 1, and I'm going to go look for the y value. This point up here would be the point 1, 3. So P of 1 is equal to 3. All right, K of 1. K of 1, here's the 1 value. So K of 1 is negative 1. M of 9.2. What's the y value? 60. So the y value is 60. N of 24. 24 points to 40. So that's equal to 40. And finally, P of negative 1. Negative 1, that's that point right there. Negative 1, 1. All right. And that's it for day 1. A lot of review stuff in there. Hopefully it was relatively simple. Wasn't that complicated. I think you guys can handle that. Anyway, that's day 1. I'm out. Catch you on the flip side. Don't forget to patronize. Is that right? Become a patron of Dunkin' Donuts. Just go to Dunkin' Donuts. Bye.